Hello and welcome. Let's talk about the C programming language. We can finally start learning a little bit about C. I want to provide a overview and give you a little idea of how C came about. So C is a general purpose imperative programming language. It supports structured programming. Now we talked about higher level languages and we described how C is a higher level programming language. This just means that it's easier and more efficient to use than writing an assembly language, understanding instruction sets. Specifically though, it's very general purpose. And what this means is you can write all sorts of applications in the C programming language. Some programming languages are very application specific or domain specific. So for example, a programming language like COBOL, you can really only use to write business applications. A programming language like MATLAB or a tool like MATLAB, you can only write certain applications. C, you can write operating system applications, you can write general programs, all sorts of different types. It's also an imperative computer programming language, which means that it's basically organized around statements, variables, things like that. If you were to study computer programming in more detail, you would see that there are different types of programming languages, things like functional programming languages or logic programming languages, where that just means that the programming language is organized a bit differently. For example, like logic programming languages just have a set of predicates and ask questions. C is imperative, a set of statements explaining what to do. So you're going to use these statements, you're going to write this line of code in your program, and essentially what it's going to do is it's going to change the state of the code or the state of the data. It's going to focus on how to get things done, and you're going to be creating variables and data and memory and algorithms and using statements to do this. It's one of the most widely used programming languages of all time, and that's just a fact. And that's one of the great reasons to learn it, is because it's used on so many different applications and so much different code. It's been around quite a while as well. It's a modern language. And what I mean by this is it uses most of the basic control structures, and these are things like conditional statements, if statements, and features of modern languages. So it has functions, it has variables, all this nice stuff that most modern languages employ. It's designed for top-down planning, which means you can start right at the top and go down when you plan. So you can start at the user interface level, and then you can go down to the lower level and actually implement lower level code. It's organized around the use of functions. So for you math people out there that understand what a function or a module design is, this is pretty basic. But functions are a way to organize your code. We're going to give a lot of examples on functions in module design. So it's not important to understand this right now, but you should understand that at a high level, C is going to be organized around this concept. And it's very reliable and very readable. Reliable means that when you write the code, it's going to do what you tell it to do. It's not going to just crash for no reason. And readable means that when you look at it and you look at the source code and the statements, that you can kind of understand what's going on if you understand the language. You don't have to kind of guess and say, well, what are they trying to do here? Or what does that mean? Or it's not complex. It's very easy to read, to understand a C program when you see it and understand after you understand the language. It's used on everything from mini computers, different operating systems, mainframes. It's like I said, it's widely used, so very useful to learn. It's the preferred language for producing word processing programs, spreadsheets, and compilers. A lot of compilers are written in C. We understood what the term compiler means from our last lecture. This is a reminder. This is what takes the source code and translate it to that instruction sets. So you can actually write a compiler, which is just a program in the C language. Very nice. It has become very popular for programming embedded systems. Embedded systems are things like microprocessors found in automobiles, cameras, DVD players. Embedded usually implies the program has to be efficient. It's running on not as much memory, not as much high-level hardware. So embedded, you kind of also think of real-time programming. And it's become quite popular in that because it is so efficient. It also continues to play a strong role in the development of Linux. And when I talk a little about the history of C, you're gonna notice why. But Linux is a very popular operating system. For those of you not familiar, it's similar to Windows. It's just a different way to interact with your computer. It's used a lot. It's the basis for the Mac operating system, Macintosh. And C has a big role in the writing of that operating system. So again, another important reason why you want to learn this language. I mentioned earlier C programs are high level, and that means they're more or less easy to modify and easy to adapt new models or languages. Another benefit. In the 1990s, many software houses began turning to the C++ language for large programming projects. Now, you may ask yourself, well, why does that matter? We're learning C, not C++. Well, the reason that matters is because C is a subset of C++. So C is organized, I told you it's organized around functions, module design. C++ is organized in terms of objects. We're not going to study objects in this class, but the reason I'm mentioning C++ is because if you learn C, you're going to know a lot about C++. And C++ is another really popular language. So any C program that you write is going to be a valid program in C++. So it's going to be great if you ever want to move on and you want to learn C++, you're already going to know half the language because you're going to know C. So very important. C is a subset of C++. C remains a core skill needed by corporations, and it always ranks in the top 10 of desired skills. Again, another reason to learn it. I use C every day at my job. I work at Xerox. I use it every day. We program on Linux operating system, and we write C applications, and we also write C++ applications. It's not an old language. It's never used anymore. It's used quite a bit. So if you're sitting there thinking, "Oh, I don't want to waste my time with C. I want to go learn something new and interesting, Ruby or something even newer like Go or something," C is still popular and still widely used and still a skill that's required by many, many industries. So by learning C, you're going to have a very marketable resume. You're going to be able to get a lot of different positions. C provides constructs that map efficiently to typical machine instructions. So we talked about this idea of a compiler, and machine instructions are at the lowest level. Because this mapping is so easy in C, it's often used by programs that were previously implemented in assembly language. And also the reason for this reason, it also is very easy to write operating system or embedded programs, like I mentioned, for this reason. So it provides low-level access to memory, and it has many low-level capabilities. It can directly interact with hardware. A lot of drivers. Drivers are programs that interact with hardware. A lot of drivers are written in C. And it requires minimal runtime support. And the reason for this, again, is because it easily maps to assembly instructions. Now, a little history about C is it's an older language. It was invented in 1972 by a guy named Dennis Ritchie of Bell Laboratories. He was working on the Unix operating system, which is a precursor to Linux. It's basically an operating system that's running on different hardware. Linux runs on PC hardware. So it's older, which is an advantage. You think it may be a disadvantage, but it's older, so it's been tried and tested. It's reliable. It was created as a tool for working programmers. The main goal when designing the language was for it to be useful and for it to be easily readable and writable. I mentioned readability is basically looking at the program and being able to understand what's going on quickly. So it's not that complex. Writability is being able to write the code quickly, efficiently, be able to do things quickly. So if you were to write some code, you don't have to write 20 lines of code to add two numbers. You write one line of code. It's very easy to write. So readability and writability are important goals and important advantages of programming languages, and C easily meets this. Some more history. It initially became widely known as the development language of the Unix operating system, and virtually all the new operating systems that were written after 1972 are written in C or C++. Okay, again, very popular, very, very useful. It evolved from a previous programming language named B. Go figure. That's why it's named C. I guess they weren't very clever, and they just said, "Hey, B, C." There's also a language called D, by the way. It uses many of the important concepts of B while adding some data typing and other powerful features. You might not have a clue what data typing is. Don't worry about that right now. Know that it added some new features from B. Mainly, B had this issue of typeless, meaning data didn't have types, and C improved upon that. It's also available for most computers, so this is an advantage, meaning that if you want to write a C program, you can write it on most operating systems. You can write it on Windows, you can write it on a Mac, you can write it on a Linux operating system. And it's also hardware independent, another important factor when writing code. If it's hardware independent, that means it's more portable. What that means is you can take the program, you can run it on a different operating system. So available for most computers means that you can write a C program. It doesn't necessarily mean it's going to work unless it's portable. So by being hardware independent means it may work on many other systems. So by the late 1970s, C had evolved into what is now referred to as a traditional C. This is what you're going to see in this class, traditional C. The rapid expansion of C working on many different hardware platforms led to many variations. So I want to talk a little bit about the different variations of C. And what this really means is there's different standards. So just like there's a Windows 10, a Windows 8, a Windows 7, there's different versions of C. There's C89, C90, C99, and C11. And this basically represents the years, 1989, 1990, 1999, and 2011. So there's standard versions of C. A program written only in standard C and without any hardware-dependent assumptions will run correctly on any platform with a standard C compiler. It's always important to have standards. So what we're really just saying here is there used to be many different variations of C, and we started to standardize it in 1989. And by standardizing, we can now run it basically anywhere. We don't have, oh, hey, Microsoft is going to release their version of C. Google's going to release their version of C. We don't have that problem anymore. We standardized it. If you have non-standard version of C, it might not work on different operating systems or different devices. So standardization is important. I mention this because I want to tell you what standard we're going to focus on and tell you a little bit about the standards. C89 is the first standard, 1989. It's supported by almost all the C compilers. Most of the code you see out there today written in C is based on C89. It has the basic constructs. And so each standard may have new features of the language and so forth. That's another reason that it's important. But C89, since it's the oldest, it's the most widely used. C99 was a little revision where it expanded on some of the functionality of C, some of the capabilities. It hasn't been widely adopted, and not all the compilers support it. But we'll be focusing on mainly C99. So the current standard is commonly referred to as C11, 2011. Not used as much, but it does have a lot of cool features, a lot of awesome different things. We'll talk about all three standards, but we'll focus on C99. And just describe a little, the C11 compiler may not implement all the language features mandated by the standard. That happens sometimes. But we'll base our examples and concepts off of C, all three standards, focus on newer concepts in C11, but mainly C99, which is the basic concepts. So I mentioned this before, but again, I want to reiterate. For all the reasons I mentioned so far, this is why C is so important. This is why it's important to learn, and this is why it's popular. And the reason for this is because people like it. It's easily to write, easily to read. And as we mentioned earlier, Dennis Ritchie's goal was to make it, to have it be used by developers. It's a developer language. So in the past decade or two, you may have moved from C to languages such as C++, Objective-C, and Java, but C is still important. And again, I'm beating this to death, but it is important. By learning C, you can easily migrate to these other languages as well. So for all these reasons, this is why you want to learn C. A basic introduction, a little bit about the standards, a little bit about the history, and now we'll dive into more details of the programming language. Thank you.